has low ionization energy. Oxygen has high ionization energy. Low electron affinity. Sorry, that does actually say, yeah. Oxygen has high electron ionization energy.
Oh, okay, that's a G.
Yeah, sorry. And it has a high electron affinity. So if you have two elements, one has low ionization energy and one has high ionization energy or electron affinity. Electron affinity is makes more sense. Then you have an ionic compound. Because this means it gives up an electron. This means it accepts an electron. Okay? Two elements both have high ionization energy and electron affinity. Neither one will want to give up an electron. Therefore, it's a covalent bond. They're going to share electrons. NaCl, and we have Cl2. What's the electronegativity of sodium? Zero 0.9. What is chlorine?
3.
So what's the difference in electronegativity? So where does that fall in the bonding continuum? Ionic. Does this have a metal and a nonmetal? So it is ionic. Cl2, chlorine and chlorine. Well, each have an electronegativity value of 3. So the difference in electronegativity is 0. So these are pure covalent. These are pure covalent bonds between the chlorine atoms. So, we've identified already that sodium chloride is ionic. It contains a metal and a nonmetal. Difference in electronegativity is 2.1, so on the bonding continuum, ionic characteristics. So it has to have both, metal and a nonmetal, and fall in above 1.7. Chlorine, 2 nonmetals, covalent, backed up with the fact that its difference in electronegativity is 0, so it's pure nonpolar covalent. The strengths of the bonds. So how do you think strength of bonds plays into this? Sodium chloride, I think it's stated in the question. Was it solid?
Yeah.
Does it state chlorine?
Yeah.
As a gas?
Yeah.
Okay. Covalent bonds are the same as covalent bonds because 2 electrons are shared between 2 atoms. So the sharing is the covalent part. All bonds contain 2 electrons. So how could this possibly be different than any other type of bond? Is different because one atom donates both electrons in the covalent bond. That is NH3. So ammonia has a lone pair of electrons, 3 bonded hydrogens because it's got a bonding capacity of 3, but it can form coordinate covalent bonds. H plus means a hydrogen atom that has lost its electron, has one electron. If it loses it, it's an H plus. So what can happen is this lone pair of electrons can donate and make a bond with hydrogen ions, forming an ion with a +1 net charge called ammonium. So this is the ammonium ion. You can't actually tell which one is the coordinate covalent bond. It doesn't look like any different from any other. It's still a single bond, but it is based on the fact that nitrogen donated both electrons. Another common one. Anybody know what this is? H2O, water. It can also donate a pair of electrons to a hydrogen ion, and it makes something called hydronium ion. We're going to be talking about that later. That's called the hydronium ion. H3O plus. Hydronium ion. What you have to do is you have to figure out how many each atom brings, because it's kind of like a potluck. You bring the electrons, then we divvy them up, okay? They're not just yours anymore. So we have got 8 electrons to place. Number 2, decide which atoms are bonded together. The central atom is usually the atom with the highest combining capacity. Who's got the highest combining capacity? Yep. It only forms one bond. It can never be in the middle. So you've got an oxygen and you've got 2 hydrogens. How many electrons are in each one of those bonds? 2. How many bonds did I just place? 2. So how many did I use up?
4.
So you subtract 4 electrons. How many electrons do I have left to place? 4. Does hydrogen need any more? Okay, so you look at the outside atoms and you decide how many do they need. Hydrogen doesn't need any more, so then the rest go on the central atom. How many electrons have I placed? 8. Does hydrogen have enough electrons? Does oxygen have enough electrons?
Yes.
Because it wants to have 8, right? Yes. So 2, 4, 6, 8. I've used all my electrons. That's my Lewis structure. And we just basically did steps 1 through 6. Okay, you want to do another one? Let's do
No,
oxygen difluoride,
Yeah.
OF2.
Is that even a thing?
It is actually.
No, you know how H2O has like water?
Yeah.
Like, what's it?
I don't know if this has a common name, but its IUPAC name is oxygen difluoride. All right. How many valence electrons does oxygen bring? 6. How many does fluorine bring? 7. There's 2 of them, so they're bringing 14. So we've got a total of 20 electrons to place. Who has the highest combining capacity? Fluorine? Fluorine?
Oxygen.
Oxygen. Fluorine only makes one bond because it only needs one electron. Okay, so oxygen goes in the middle. Fluorines go on the side. How many have we placed? How many electrons? 4, so that leaves us with 16 electrons. All right. So, take your terminal, your outside atoms. You start by placing electrons there first to complete their octet. So fluorine on the left right now has 2. It needs another 6. 2, 4, 6. I've used up 6 electrons. Now I have 10 electrons left. Okay? Now the other fluorine, same deal. It's got 2 electrons. It needs another 6. Leaves me with 4 electrons. Fluorine's happy, surrounded by 8 electrons. Oxygen currently is surrounded by 4. I happen to have 4 electrons left. How convenient.
Doesn't this seem like magic?
Magic.
Yeah.
That's the thing though. It's chemistry.
Try nitrogen, try oxygen.
All right, carbon brings how many valence electrons?
4.
4. Oxygen
Six.
times 2,
12.
so 12 electrons. I want you to get in the habit of doing this. I show you how to do it because it works. Don't invent another way to do it. 16 electrons. And don't get lazy. Don't try and skip because you actually make mistakes that way. So we've got 16 electrons. All right, who's got the highest combining capacity? Carbon, so it's going to go in the middle. The oxygens are going to go on either side. If you have 2 of something, chances are one's on either side, okay? So, put a bond between them. We've used up 4 electrons. I'm going to show you how the magic works. We've got 12 electrons left. What do? We put them around the outside. So oxygen's got 2. It needs another 6. That leaves 6 electrons. Do the same thing to the other oxygen. I've got 0 electrons left. Now, oxygen, is it surrounded by 8? Awesome, it's happy. How about carbon?
No.
No. But we've run out of electrons. We have no more to add. When you're short on the central atom, you make a multiple bond. So what you do is you take a lone pair of electrons and you make a double or a triple bond between the 2 atoms, okay? The central atom and yourself. So, do that and then tell me how many electrons carbon has. Yep. I take this lone pair and make another bond here. Ivy, you're shaking your head no. How come? Because it doesn't work. Do you guys know why it doesn't work? For good. It doesn't work.
Her reason was pretty good though. She said it doesn't look good.
It doesn't look good. There's an actual, if you look carefully at this, you'll find your answer. So, how many bonds does carbon have?
4.
How many bonds can it make? 4. It will always make
Oh wait,
4.
oxygen can't make 3, it can only make 2.
Yeah, there you go. Right there. There's your problem. Oops. There's your problem. Oxygen cannot make 3 bonds. It's got a combining capacity of 2. So your structure looks like, oops. I was too quick. Your structure is going to look like this. So, always double check. 2, 4, 6, 8, 10, 12, 14, 16. Did I use the same number I had to start with? Yeah. Does everybody have their octet satisfied? Yes. Is anybody breaking any rules? No. Okay. What you do when you have a charge, if it's negative, you add to the total number of electrons that you have. Okay? I've got a 1 negative charge, so I'm going to add 1 negative to my total electron charge. Then if I have a positive, I'm going to subtract 1. Your total electrons should always be an even number. Why? You're either going to have a lone pair or a bonding pair. Pair means 2. So you're always going to be even. So let's do this. Nitrogen brings 5. Oxygen brings 6 times 3 is 18. Plus 1 for the negative charge, 24 electrons. So, nitrogen's got the highest combining capacity. So put the oxygens on it. So how many did we use? 6. So that leaves us with 18. So let's start putting them on. 2, 4, 6, 8, 10, 12, 14, 16, 18. Ooh, just enough. So, what do you notice? Is this... We've got 0 electrons. Does everybody have their octet filled? Except for nitrogen. We can't leave nitrogen hanging. This is going to be one exception. Nitrogen will form a double bond and end up with a combining capacity of 4. Yeah. So, if you are ever short on your central atom, you make a double bond. If you're still short and one has a higher combining capacity, you can even make a triple bond. Because it's a negative charge, we put square brackets in the negative charge.